G'day and welcome back to Mathematics, Australia's largest YouTube channel. Today I'm tackling something that I've been putting off for a couple of years because I couldn't find a good way of doing it basically. Finally put in the hours and have landed on something that I'm pretty happy with. So I'm taking you through a graphing guide for Extension 1. This is for the prelim course, but obviously useful for HSC students as well. I'm going to run you through the typical graphing transformations we are expected to be able to apply in the Extension 1 course and show you a few examples as well. All right, let's get right into it. Let's start off with a pretty generic parabola, x squared minus 4x, and we're going to apply a bunch of transformations to this to get us started. Okay, we have a concave up parabola. If we found the x-intercepts, they would be 0 and 4. And if we could be bothered to do some calculus to find the turning points, it would actually be at minus 4. So here's what our parabola looks like. Okay, starting off simple with just looking at the negative of this function. So taking a function and multiplying it by a negative is just going to flip your picture across the x-axis. So our concave down parabola becomes a concave up parabola. So that's a negative at the front of the function. What about if the negative is inside the function, f of negative x? This is also going to be a reflection, but instead of a reflection across the x-axis, we're going to reflect the x value. So we're reflecting across the y-axis. So instead of going left to right like this, we go right to left, and it's the exact same shape, but just a reflection across the y-axis. Okay, stepping up now, looking at the absolute value of f of x. What happens here is the absolute value is taking any negative portions of our graph, and by negative portions, I really mean negative y values, which are down here, and it's just going to reflect these up and make them positive. So the positive parts of the original function remain unchanged, but the bottom part is just going to flip up and be reflected. So now our entire graph is above the x-axis. Okay, and also we should look at what happens when you put an absolute value inside of the function. So we're looking at absolute function of absolute value of x. What's happening here is that all of our negative x values on the left here are being absolute valued, and they're turning into positive x values. So all of our values on the left here are going to become the values on the right, and that leads to a reflection across the y-axis again. So this left-hand side is going to become the right-hand side. So the right-hand side is already good to go because these x values were already positive. Changing these left-hand ones to become the right-hand ones, we end up with this picture here. So we're just taking the right-hand side of the y-axis and just reflecting it across to make this cool W shape. Okay, up next, getting into the trickier ones now, we have the reciprocal graph. This one's pretty commonly assessed in Extension 1, so probably the most important one from today's video. Okay, a few things to consider here. First of all, we need to recognize that we cannot do 1 divided by 0. So when I'm doing one of these graphs, the first thing I do is I go to my original function and see where is this thing equal to 0. It's equal to 0 in terms of y at x equals 0 and x equals 4. So these two x-intercepts in our new graph are going to become asymptotes. So I'm just going to draw the original function as like a dotted line so I can sort of graph around this. This is a really good tip that I recommend for all my students. When you're doing a transformation like this, redraw the original graph but do it dotted, and so you can sort of play around it and do a pretty accurate graph. Okay, then like I said, where we have our zeros, we're going to have asymptotes that we cannot cross because we cannot do 1 divided by 0. Now for these, I like to think about my 1s and my negative 1s because the reciprocal of 1 is 1 and the reciprocal of negative 1 is negative 1. So I'm going to put dots on my original graph at y equals 1 and also at y equals negative 1 because these are going to be the same values in my new graph. So it's going to be where these two are intercepting each other. Okay, now we're going to go through some really technical mathematical language, which is 1 divided by a very small number gets you a very big answer. If you think about 1 divided by, I don't know, 0.1, you end up with 10. So when the bottom of your fraction is a very small number or a very small y value, that's going to output a very big y value. And the inverse of this is true as well. If I do 1 divided by a very big number, I end up with a very small number. What I'm trying to get at here is where my original graph is going up to infinity and becoming really big numbers, my reciprocal graph is going to be approaching 0. So we're doing the inverse relationship here. Where this one gets big, our new one's going to get small. Where this one gets small, as this thing approaches 0, that's where our reciprocal is going to be really big and it's going to fly up this asymptote here. So I'll show you what I mean. Here's the one on the right-hand side. Towards the right, as x is becoming large, our reciprocal function is becoming small, so we are approaching 0, approaching the x-axis. Now, as this thing gets towards 0, so we're doing 1 divided by a very small number for the blue, the green is going to become really large and trend up to infinity, but never crossing this asymptote just here. Same thing's happening on the left, approaching 0 this way, and then approaching infinity this way up the asymptotes. And now for the bit in the middle, when I'm going to go through here, and we're going to go through here, and we're going to approach these green asymptote lines, what's happening in the middle is that this original minimum turning point is going to be transformed into a maximum turning point. Because the original value down here for y was -4, when we reciprocal that, we're going to get -1/4, which is about here. So we're going to come up our asymptotes, go through -1, hit this point here for a maximum turning point, and then go through the -1 again, and then approach the asymptote as the blue line approaches 0. So it looks like this. So that's my strategy for approaching these. Start off with a dotted version of your original. Look at your ones, look at your -1s, minimum turning points turn into maximum turning points, so on and so forth. All these little facts can help you quickly build a good outline and give you a really good sketch to get your full marks. So hopefully that's useful to you. Okay, for the next one, we are looking at the square root of a function. So square roots, I like to start off by considering the part below the x-axis. Below here, all these y values are negative, and we can't do the square root of a negative number in this course. It doesn't give us a real answer, so it's not going to give us a real graph. So straight away, everything down here is not going to be a part of our domain, and there's just going to be blank in our transformed graph. Once I've recognized that, I then think about my zeros and my ones, and I put them, so I've got my sketched out dotted one again, putting on my zeros and putting on my ones. Now, the reason I've done that is because the square root of 0 is equal to 0, and the square root of 1 is equal to 1. So these 2 points are where my new graph is going to go through. Okay, now to do a really good sketch for the next part, a cool little fact to consider is that when you do the square root of a number between 0 and 1, normally when you do a square root of a number, like square root of 25, you get a smaller answer, which is 5. However, between 0 and 1, when you do a square root, it actually makes it bigger. Like, for example, the square root of a quarter is a half. So square rooting this number is making it bigger. Why that's important is because our new graph between 0 and 1 is going to be above the original, and then it's going to intercept through 1. And then for numbers bigger than 1, that's when the square root is going to make us smaller. So that looks like this. Going up through there and going up through there. Okay, between 0 and 1, the transformation is above the original, and then from 1 and beyond, the transformation is below the original because square rooting the number is making it smaller. Okay, so that's how we do a square root graph. Last one to consider, or maybe second last one, is a very similar idea. It is sketching y squared is equal to f of x. Now this is similar to before because I can take this equation and I can just do the square root of both sides. The left-hand side, the square root will just give us y, and the right-hand side will give us the square root of f of x. But you just got to remember to do your plus minus. So this graph here is going to be the exact same graph as this one. And in the last slide, I showed you how to graph the square root. We're just going to chuck that back on again. And now to do plus minus, we've already got the plus. We'll just do the minus by reflecting this across the x-axis, and then we get this funky looking shape for our square root relation. Y squared equals f of x. Looks like that. Okay, and one last one, which doesn't commonly get asked, but I'm just putting this in just in case. What if we wanted to graph the square of a function? So we're starting with a different parabola now. We've got a concave down one to make a bit of a more interesting shape, and we're going to square this. Okay, so we're going to put a dotted version on so we can play around it. Now, thinking about squares, I'm also going to put on a bunch of zeros and a bunch of ones. Okay, there's my 0, there's my 1, there's my 1, and there's my 0, because 0 squared is equal to 0, and 1 squared is equal to 1. So these points are going to be the same on the transformation. Now let's put some other points on. We can put on our negative ones, because when I square -1 down here, the y value of -1, squaring that turns it into a 1 and puts it up here. Same thing happens on the left. This -1 gets squared, turns into a positive 1, and goes right there. One more I can chuck on is that my original maximum turning point was at y equals 2, which is very convenient because when I square 2, I get 4, and I can put that up here. Putting these points on gives you already a pretty good outline of what this thing looks like. We're going to be coming down here, hitting the 1, turning on the 0, hitting the 1, turning on the 4, and then doing the same thing over here. So here is our sketch of our function squared. Our parabola, which was a degree 2, has now turned into a quartic, which is a degree 4, because when you square 2, you get 4, obviously. Okay, there's the speed run. Let's run through a few examples and try and solidify some of these concepts and get you HSC ready. Here's our first one, starting off slow. This one was actually from an HSC paper a couple of years ago. Well, part B was at least. We have a parabola shown right here. We've got x-intercepts of -2 and 2 and a minimum turning point at -3. Now, part A, which I invented, is we are going to sketch the absolute value of this, and then for part B, we're going to sketch the reciprocal. If you're brave, you should pause the video and have a crack first, because then my solution will be more meaningful to you and hopefully will be the same as yours as well. Okay, for part A, the absolute value. So first of all, like we said, the positive values are going to remain unchanged. So I'm just going to draw my sketch originally. Everything above the x-axis is going to remain as is, but the absolute value is going to take this part down here, which is negative for y, and it's just going to do a cool little flip. Some technical animation at Mathematics Studios. Flip that up to become positive, so reflecting the negative part above the x-axis, and that right there is our absolute value sketch. Okay, that was the easy one. Now for the harder one, we're going to do the reciprocal by running through the same tips I showed you earlier in the video. So we're going to start off with probably a couple of asymptotes. Wherever our original graph is equal to 0, which is your x-intercepts, we're just going to do some dotted vertical lines there as our asymptotes. Okay, now we can't be super accurate with this graph, but we're going to try and chuck on some dots where we think our ones and negative ones are going to be, because like we said before, the reciprocal of 1 or -1 is 1 or -1. So I'm going to eyeball and say 1's probably about there, and then 1's about there, close enough. And then down here, we're going to say -1's about there, and -1 is about there. Okay, now we're going to apply the same logic from before, which is where, to the right, as this curve is becoming large and approaching infinity, the reciprocal of that is going to approach 0. So long term on the right, we are going to be approaching the x-axis. Same shape on the left-hand side here, approaching 0 as we move to the left. And then down below here, our minimum turning point of -3 is going to be reciprocaled and become a maximum turning point of 1 over -3. So at about -1/3. So there we've got the right-hand side, the left-hand side, which are the same thing. If -3 is there, the reciprocal of that is -1/3, which is going to have to be about there. And then we have our turning points, and then we have our shape, and we've got our frowny face. Okay, so that right there is our reciprocal of this quadratic graph, very similar to the one from before. Okay, sorry, I'm a little bit sick, so if I sound a bit blocked up, it's because I am. Okay, example 2, I think we're going to do 2 or 3 today. Here's the second one. We have this funky looking graph that I stole from a very old extension 2 paper, I believe. All this further graphing stuff used to be in extension 2, and these days it's extension 1, but who cares? Why am I talking about this? Okay, for part A, we are going to sketch the function of absolute value x. So, linking back to what we were saying before, when we are absolute valuing, which is not a verb, the input of our function, it means that the left-hand side, where our x values are negative, the absolute value is going to make them positive and give you the same picture as the right-hand side. So the right-hand side is already the same, and I tried to trace that out as best as I could, so you'll have to just settle for that. The left-hand side is going to become the same as that because the absolute value is making the negative side the same as the positive side. And it gives us this cool little mustache shape, which I think is quite cool. Maths is cool. And that right there is our absolute value of the input of the function. Okay, for part B, we're going to sketch the function squared. So the tips I gave you for that one is to start off with your zeros and start off with your ones and maybe even your -1s if you're really desperate, because the square root of 0 squared is 0 and 1 squared is equal to 1. So I'm putting the dots on the ones as well, which is that convenient horizontal line. Okay, we've got our shape now. We're going to be, and remember, because we're squaring, any negative values down here, when you square a negative, they become positive. So we're never going to go below the x-axis. So we're going to be coming down here, hitting the 0 and turning around. We're going to be shooting up through this point here, and then because our maximum turning point here is above 1, when you square a number that's bigger than 1, it makes it even bigger. So we're going to be climbing even higher, somewhere up here, doesn't really matter. Coming back down, hitting through the 1, going down here through the 0, turning around because we can't be negative because we're squaring something, turning around and then flipping up, turning around again, and then up through here. Looks like this. Oh, that was beautiful. All right, it's a big polynomial, but importantly, the features you want to show is that it's going through the same points at 0 and 1, and it is never going below the x-axis. Those are the critical points for a question like this. Okay, and then for question C, we're going to sketch y squared equals f of x after we clear that away. And so to approach this, we're just going to remember that this is the same thing as taking the square root of both sides with a plus minus. So to sketch y squared equals f of x, we're just going to sketch the square roots, and then we're going to do plus and minus, reflecting it above and below. Okay, so for our square roots, again, the parts below the x-axis where the y value is negative, we're just going to ignore these because we can't do anything there. We can't take the square root of a negative. We are going to chuck on some zeros and some ones from before because the square root of 0 is 0 and the square root of 1 is 1. Okay, now, as we said before, between 0 and 1, when we do the square root, it actually gives us a bigger answer. So our line is going to go above the original up to here. And then for these values above 1, the square root makes it smaller. So we're going to be turning around below here, going through 0, and then being above the original. Then we're going to stop here because we can't do anything between 2 and 3 because we have negative y values that we can't take the square root of. And then between 3 and here, we're going to be above and then hitting through at 1. And then from the right, we're going to be below because we're square rooting a number bigger than 1. So here's our shape, up through there, turning around, down here, skipping that, and then going up through here, and then off henceforth. Okay, that's the hard part done. That's the square roots. Now we're just going to do the plus minus, which is just already got the plus right here. Now we're just going to do the minus below with a little reflection. And we make this cool little fish shape, which is very neat. So fishy shape for y squared equals f of x on this one. Okay, and we're going to finish off with one more example, I think. Yeah, tough one. All right, we're starting off with a function. It's a quartic function, 4x squared minus x to the power of 4. And we're going to sketch not only the square root, but the reciprocal of the square root. Okay, so to dive in, we're going to have to know what our original function looks like so we can do some transformation. So what can we do with this equation to figure out how to graph it? If we want to graph it, we should figure out our x-intercepts by setting this thing equal to 0 and seeing if we can factorize. Fortunately, we can factorize because we have a common factor of x squared that I can yoink out the front and give me 4 minus x squared, which is conveniently a difference of 2 squares, which can be further factorized into 2 minus x and 2 plus x. So now looking at this, if this was equal to 0, my critical values, or my x-intercepts, would be x equals 0 as a double root, and single roots at 2 and minus 2. And so remember, when you've got a squared value like this, it means that the x-intercept is also going to be a turning point. So we have a turning point at x equals 0, and then intercepts at 2 and minus 2. Okay, because we know the shape of a negative quartic, it looks like this. It's kind of like an M upside down. Now we get a pretty good idea of what we're looking at. There we go, passing through at minus 2, turning around at 0 as an x-intercept as well, turning around up here, and then an x-intercept at 2. Conveniently for this question, these turning points up here are happening at 4, which we could have proved with a bit of calculus, but I'm trying to get you through this course as quickly as possible, so we skip that part for today. But trust me, that's what this original function looks like. Okay, now, before we do the reciprocal, let's think about the square root, and then once we get the square roots, we can then reciprocal that, and then we'll be done and dusted. So we're going to do that in blue. So for our square roots, once again, running through the logic, first thing I think is that anything below x is just going to be white because I can't do the square root of a negative. I'm going to chuck on some zeros and some ones, which are plenty of those because that's where we're going to get the same answer. And now I'm going to try and show, it's hard to do on a computer, but I'm going to try and show that between 0 and 1, I'm going to be above the original, and then between 1 and everything else, I'm going to be below the original. So my turning points originally was at y equals 4, and the square root of 4 is 2, so I can put some dots on the 2's as my new turning points, square rooting 4. Okay, now I've got a good idea. I can trace it out and go up here, down there, hit that, and then sharp bounce. That's not a turning point there, it's a little sharp bounce. Up through 1, turning it 2, and then back around here, and we get this cool M for McDonald's. Not sponsored, but I'm very open to being sponsored by McDonald's, so hit me up. All right, now we can go on to the next part, which is taking the reciprocal of this graph. So running through our reciprocal logic again, wherever this thing is equal to 0, we're going to chuck some asymptotes because we can't divide by 0. So we're going to have 3 asymptotes here. We're going to have 1 here, and 1 is the y-axis that I couldn't be bothered to do, but just imagine there's a green dotted line there. Okay, reciprocal's done. Oh, sorry, the asymptote's done. Now for our reciprocal, we are once again thinking about our 1's because the reciprocal of 1 is equal to itself. So I'm going to put some green dots on those 1's. And now for my turning points, I know that for reciprocals, the maximum turning points become minimum turning points, and the reciprocal of positive 4 is positive a quarter. Sorry, the reciprocal of 2, pardon me, right here. Reciprocal of 2 is a half, so I'm putting dots at a half, and that's going to be my minimum turning points. That gives me a pretty good idea of what to sketch now. I'm going to come down very close to the asymptote, hit through the 1, turn on the half, hit the 1 again, and then back up to the new asymptote, which is the y-axis, and then do the same thing over on the right-hand side to create this cool little graph for 1 over the square root of f of x. So that would be a very high-level question in the Extension 1 course, but now if it comes up, hopefully you know how to handle it. All right, that about does it for graphing in the Extension 1 course. So thank you so much for watching if you made it through to the end. Hope that helped you feel a bit more confident in doing some sketches for your HSC. Also, quickly, if you have a friend who is fortunate enough to be blessed by Extension 1 mathematics in their lives, maybe flick this to them and see if it will help them get ready for their HSC or trial exams. All right, that's all for today. Thanks for watching. I appreciate you, and I'll catch you in some more revision coming very, very soon. Bye for now, not forever.